Okay, now solve the number of islands. Here we have given m cross n 2D binary grid. So basically binary means 0 and 1. So in this question, like 1 represent land and 0 represent water, and the question is question is saying basically we have to return the number of islands. So basically we have to count the number of islands, and all connected ones are called to be single island. So basically here we have 1 means land and 0 means water. So 1 means land and 0 means water. So for this question we can use a DFS and a BFS algorithm. I'm going to use a depth first search algorithm. So for that I have created a visited matrix for this adjacency matrix. So graph is represented over in adjacency matrix, and if the DFS, let me start with the DFS call of 0, 0. So it's DFS of 0, 0. So from that we can move all the 4 directions. We can move like left, we can move up, we can move right, and we can move bottom, but left is invalid and the top is invalid because nothing is there, and the right is invalid because water is there, and we have to find a connected one in order to make our island. So right is water and the below is 1. So this is a valid move because we have 1 and we can move from 0, 0 to 1, 0 because it's a land. So let's now move from 0, 0 to 1, 0 and mark the 0, 0 as visited, because basically we are marking, so there is no need to visit again. So we have marked 0, 0 as visited, and now we are making DFS call from 1, 0, and from that we can move up, bottom, right and left. So from that we can move up, but the up is land, but up 1 is already visited, so there is no need to visit again. So from that we can move to the right of it. So from 1, 1, and from 1, 1 we can move to 2, 2 because there's no other moves, all are surrounded by water. So these are all going to form a single island. So I think I forgot to add the DFS calls. So let me write it. So it's going from 0, 0 to 1, 0. It's going to be 1, 0, not 0, 1, but please understand it. And from 1, 0 we are going to be 1, 1. So again from 1, 1 we are going with 2, 1. Okay, so from 1, 1 we are going to make DFS call 2, 1. Okay, then from nothing is there, all are waters, then go back and go back. From that, okay, from 0, 0 we have make a DFS call because it is a land. Now we are iterating. Now we are going to move 0, 1 and 0, 2. See, these are all lands, but 1, 0 is, so 1, 0 is like a land, but there is no need to visit, and it visited again, and same for 1, 1. So these all are water, so there is no need to make a DFS call. But if we reach at 5, 1, so this is a land, so make a DFS call to make a DFS call from it, so we can visit all the neighbors. So if we make the DFS call from 5, 1, so basically we can visit all the neighbors, but at the top of it we have, let's make a DFS call first. DFS call from 5, 1. Okay, so 5, 1 we can visit left, but it's water. We can visit up 4, 1, but it's water. And from that we can move down, but it's invalid. We can move right, so we can move right because all the moves from it, left, bottom, up, all are invalid. We have only one move, and which is land, so which is 5,4. So okay, oh no, 5,2. So we are going to make a DFS call from 5,2. So these are the valid, so these are going to form a single island, and we side by side we have to mark the visited, so there is no need. So mark the visited and just increment the island count, so which is 2. Now from 5,2 we can like move 5,3, but it's water. So now let's update the DFS call, which is going to be 5,2, and from that we can, from that 5,2 we cannot move anywhere, so there's go back, nothing is there. Left is water, up is water, right is water, and below is invalid. So if we like move 5,4, which is land, so from that we can start a DFS call. So we make a DFS call at 5,4. so let's write it, but the top is water, left is water, below is water, and right is water, so there is no need to go anywhere. So only we have make like 1 2 3 4 5 6 7 8 DFS calls to get our result. So total number of islands is going to be 3. So let's move to the coding part. So we are going to solve it on a Leetcode. So okay, so let's start with the coding part. Okay, so firstly we are going to let me write some comments. Okay, so we are going to create a rows, like we are going to find the rows, how many rows, what the length of the row. So it's a row, and then we have going to get the number of columns. So let me comment it, column. Okay, now then we are going to create a visited array, visited matrix, like I already shown you, where we have to mark. Okay, we have to mark like if we have already visited, so there is no need to visit again and again. So this will reduce the unambiguity. Okay, so let me create a visited array from that. Okay, so okay, for underscore in range column a row. So this will create a visited matrix with initial value of 0. Now we are going to iterate on the grid. So we are going to iterate on the grid, and if we find anyone from anyone, so and it's not visited, so we are going to create we are going to make a DFS call from it. So for n range row and for C in range column. Okay, so let me comment it properly. So if we find, let me write it, like if it is land and not visited, then we are going to make a DFS call. So it's a very easy. If grid at row and column is equal to is string 1, so make sure it's string and it's not visited. So visited at row and column is equal to 0, so that means it's not visited. So that's point I'm going to make a DFS call, and make sure pass the row and column, visited, and the grid, so we can take as a reference and perform the action on it. So let me write our DFS function over here. So let me write it, let me write the comment. Okay, DFS of row comma column and the visited matrix and the graph, we are going to get the graph. Okay, let me, okay, wait a second, let me write the def. I just forgot it. Okay, let's mark the visited row and column. Like, let's mark the row and column visited because we are going to make a call for row and column. So firstly we have to mark as visited. So I have already shown you in the diagram, so let me show it again. So if we are making call from 0, 0, so firstly we have to mark it visited. Okay, so we have, okay, so let's so from that we are going to move up, bottom, down. So from that we have to move several directions. So we from 0, 0 we can move up, we can from 0, 0 we can move right, and from 0, 0 we can move left, and from particular 0, 0 we can move bottom. But these are the 4 moves, but only thing we have to check the validity. Like, we can check is it 0, 0, left is valid, right is valid, and top is valid. So firstly let me create the direction. Okay, so from 0, 0 we are going to move 4 directions. So let me create the directions, all the direction we are going to move. Okay, so let me write the comments for better understanding. Okay, let me create the direction array. It's going to be tuples, array of tuples. So from -1, 0, and 1, 0, and 0, -1, and 0, 1. So I'm going to iterate on this particular direction. So we are going to get the direction row and the direction column. Let me write the comments. Okay, so from that particular direction we are going to get the 2 things. We get the rows and columns, and we are going to add it what the direction and what the row and the column we have. So we get the new row and the new column, which is like I showed you in the diagram. I try to move all the 4 possible direction which is valid. Okay, so let me create a new row and a new column by adding the, okay, let me iterate it, I forgot it. So for direction row and a direction column in directions, okay, let me paste it, and we are going to create a new row and a new column. So it's nothing, we are trying to move all the 4 directions. So we're just adding the row with the direction row and column with the direction column. And now we are checking the inbound, like the row and a new row and a new column is inbound. If it is inbound, then we are going to proceed it. So n row if greater than 0 and less than row, and call is greater than equal to 0. So it is greater than equal to 0. Okay, so and call is less than call, and now we are going to check if the all the in left, right, or bottom, if it is 1, then we are going to make a DFS call from it. So, and it's not visited, so I'm going to check grid at new row and the new column is equal to 1, and it's visited is equal to 0. That means it not visited. So let me write it, and call is equal to 0. So that means it's not visited. So from that we are going to pass the n row, n column, visited matrix, and the graph. So that will make another DFS call if it is valid and if it is a land. So let me write the total number of island where I have to return the result. So if it is, from that we are making no DFS calls, so we can increment it by 1. So if it is so if condition is only valid if it is land and not visited, so it will count the number of islands. So we are going to return it, the number of islands, and let me run it. Okay, so it's accepted. Let me submit it now. Okay, now so it's submitted and it's pretty efficient. Okay, thanks for watching. Please hit the like button and subscribe and follow and share it